Welcome everybody to this session where we're going to discuss two of the topics that I am very passionate about. The first one is LangChain4J, which is the framework for developing AI applications. And the second one is context engineering, which is as an engineering discipline. It's a pattern that I think is very important for us if you are developing AI applications and you want to control a little bit of what context is going to be sent for the LLM. So I'm going to kind of tell a story here with this presentation. So the whole point of this presentation is, yes, talk about context engineering, talk about LangChain4J, but also tell a story about how my interest in this actually started, right? First and foremost, my name is Ricardo Ferreira. It's very nice to be here with you and the JDConf 2026, and I hope you're enjoying the conference. And I work at Redis as the lead of the developer relations team. So by the end of the presentation, I'm going to make available my LinkedIn contact. So feel free to add me there. And I hope actually you do so, because by the end of the presentation, I'm going to share with you a hands-on workshop about all of this that I'm going to show. And please add me on LinkedIn so I can help you if you intend to do this workshop by yourself, right? So with that said, so the story that I was mentioned before is that I'm always has been a huge fan of the idea of Alexa devices at home, right? And by the way, I'm actually going to put my one here on mute because I know that throughout the presentation, I'm going to say the name Alexa for multiple times. So it's going to be popping up a little bit. Because I think the idea, and in a minute, I'm going to explain why I'm referring to this idea of having an Alexa device at home is good. Because in reality, most of the time, the device is not necessarily very useful as you would expect them to be. So the reality is that most of the time, you kind of spend like re-asking questions and explaining in details exactly what you want, so the device can actually be useful, right? So one good example, that example happened a few years back, because my son now is 14 years old, but back then when he was a toddler, right? Not a toddler, but he was grown up, right? Still a kid. He would go in school and then, hey dad, what is the American president during the 60s? And I mean, I had no idea at that time. Like, that's the type of information that you don't know from the top of your head if you're not American, at least. Like, I am from Brazil originally, so I've been living here, which is different, right? And then I said, oh, let's ask Alexa for this, right? Because the device is supposed to know all of this stuff. And that's one of the situations where we asked Alexa and then said, I don't know that one, which is the typical answer when Alexa kind of doesn't know anything, right? And then I've always a little thing about me, right? If you don't know me personally, and probably you can figure it out by my background as well. I hope you can see my background, but if not, I can explain what it is. Like, there's a bunch of superheroes from Marvel here, posters of them. So I'm a huge fan of Marvel heroes, right? And particularly one of them is Iron Man, right? And then, I mean, I always felt really cool about Iron Man's AI technology called Jarvis, right? Where he can basically make interactions and explain his intentions and what he needs. And then the AI basically does everything for him, right? In a very autonomous way, right? So I thought, hey, why I don't create my own Jarvis, right, for Alexa? Because first and foremost, I know the idea works, so it's it's very compelling to me, and I particularly know how to develop skills for Alexa. Like, that's one of the skills that when I worked for AWS, I kind of learned how to do this. So that's what I did. Like, as an engineer, as we all are, right? Like, when we have some idea that we want to execute, we go down, write some code, and then we come up with a solution for this. So this is the repository that you can actually have a copy of not a copy, actually, the code that I've created for my Alexa skill. I call my Jarvis, right? I couldn't call Jarvis because some trademark issues with Marvel. So I call, okay, my Jarvis, right? And then it is basically does what it's supposed to do, which is I put some brains behind Alexa. So every interaction that goes through Alexa, it uses this implementation that I have done, and then it uses an LLM in the end. Like in this particular case, I use an OpenAI, right? And this is a screenshot that I actually took here is from my office that I'm right here. And this is me actually asking Alexa for a bunch of things. And what you're looking at right there is exactly Alexa telling out loud the answer and also showing on the Echo display, right? Which is pretty cool. So basically, my original development for this, right? I kind of tried to come up with something that could be really, really useful. And my first decision when I start developing this was, okay, I need a framework to start helping me to develop this, right? And then that's when I kind of started like taking LangChain4J more seriously than before. I had worked with the framework before. I actually contributed some code for the community projects a little bit, but I have never used it in a real project. So that will be my first one, right? So, and the reason why I picked LangChain4J and not, for example, Spring AI, which is awesome, is an amazing framework, right? But there's a very peculiarity of like Alexa devices that each interaction end-to-end, request and reply, needs to be executed within the 8 seconds timeout. That's a kind of a built-in premise of Alexa, right? So one of the characteristics of Spring AI is that, I mean, because it's built on top of Spring Boot, is that there's a whole considerable bootstrap that actually takes place. And as you may know, I mean, Alexa devices are backed by Lambda function. Not sure if you know this, but you have to come up with a AWS Lambda function in order to do this, right? And they are short-lived. So by the time you are not using it, the container behind it are disposed, so they are ephemeral, right, by default. So the next interaction is going to create a new one on demand. So imagine bootstrapping the whole like Spring AI, all of this. Like I said, like Spring AI is amazing, but it has a footprint of like bootstrapping. Yes, I could solve this with like a Graal VM. I could solve this with like pre-compilations. I could solve this by backing up with Docker container images. There was a bunch of solutions that I could have pursued, but then I realized, why did I just like use like a more lightweight framework? And LangChain4J fits into the category. So that's the first thing you have to know about LangChain4J. If you're looking for something really lightweight, I think LangChain4J is your thing, right? Functionality-wise, feature-wise, I think it's kind of an imperative with what Spring AI supports. So it's not that one is better than the other. It's more about the behavior of the runtime, right? So the way you start developing with LangChain4J is this, that you come up with an interface that describes your, let's say, conversational behavior, right? So I come up with a method called chat, right, which is kind of very simple. That's going to take as a parameter a system prompt and a query, which is the question that the user is asking. And it's going to return a string, right? And then you annotate with this at system message. So it's going to reuse whatever prompt has been passed as a parameter. And then this at user message is the indication that, okay, this is the actual user prompt. So you can differentiate between the tools, right? So those are LangChain4J annotations, right? And then your second step to start using the framework is come up with a chat module, right? This is basically an interface. So that's kind of a abstract implementation that describes a behavior, and the LangChain4J provides you with multiple implementations. Like I mentioned in the beginning, I ended up using OpenAI. So that's how I kind of created this OpenAI chat model, call the builder. Here's the API key. I want to use this model, the temperature, max tokens, blah, blah, blah. And then you build it, right? So the same process if you want to use like Anthropic, for example. You're going to have like a builder for Anthropic. So the process is going to be the same. What really matters is that you ended up like instantiating a chat model, right? So once you have the chat model, you can optionally come up with your own tools, right? In my case, in particular, I had to come up with very peculiar tools for handling date and time. Like Alexa can be incredibly complicated when it comes to time zones and dates and times. Not only Alexa, I think any implementation for the sake of the argument, right? And then I have to kind of teach like things like, okay, if today is Wednesday, so if I want to schedule something for next week, so you have to teach like this idea of how to jump like a week or a month, you know? So I have to come up with tools, and the way you do this is basically coming up with classes, and then you annotate these methods with at tool. Very simple. And then you describe the intention, and there you have it, right? And then finally, this is what you do for the first time. Like you come up with a chat assistant. Remember, this is the interface that we've implemented before. You're going to call what we have in LangChain4J called AI services, right? So one heads up, this is specifically for you to come up with like AI applications. There is a different constructor or construct for you to create agentic applications in LangChain4J. So there are differences that you can apply here. Although the model is going to be similar, right? And then you are going to provide the chat model, the list of tools that you have available, and then you're going to build it. So once you have the instance of your chat assistant, which is my interface, I can simply, hey, chat assistant, dot chat, which is the method that I've created. Here's the system prompt, here's the query, here, and here's the response. Obviously, this is only to focus on the LangChain4J type of things. What I actually put in my implementation behind the Lambda function that is backed in the Alexa skill, there's a whole like invocation framework that's very peculiar to the Alexa skills toolkit for Java. But in between the whole backend implementation, that's what you would see, right? And that GitHub project that I shared before, right? And then voila, like I actually got my first test with exactly the question that I originally asked it for Alexa when I was super frustrated about her lack of intelligence, right? So I asked, what was the American president during the 60s, right? Oh, it was John F. Kennedy. And by the way, he was the 35th president, blah, blah, blah. So he actually was able to come up with a very descriptive and useful answer, which was I was looking for, right? So yeah, like Dob John, right? So everything that I needed, I would have it. And kind of, right? So one of the questions that I tried to do when I start using on my daily basis, because I was super excited and kind of leverage my Jarvis, right? Which was, oh yeah, my name is Ricardo, by the way. I started introducing myself, and nice to meet you, Ricardo. So it's very polite, the first response. And then I would like subsequently ask, hey, my Jarvis, can you recall what is my name? And then, oh, apologies, I don't know you, right? Oh, yeah, because you know what? Models and LLMs are stateless. So that's one of the things that you have to keep in mind when you are developing applications like this, like user-focused applications like this, or for the sake of the argument, any AI applications, right, that you are developing, right? So every request is a blank slate. You have to take care of this. So that's why I kind of start leveraging what we call in the AI world, like I need to have a memory layer, right? Something that remembers, right? At least specifically for two types of memory, like what we call short-term memory, right? Conversations that are ongoing at a certain period of time, or sessions, if you will, as we call it, or long-term ones, which are memories that has to endure and has to persist over the courses of multiple sessions or multiple conversations, and they're not necessarily is going to time out or be deleted in a certain point of time, right? So that's why I leverage in my implementation a framework. It's a framework more like an open source project server called Agent Memory Server, right? So this is an open source project that Redis is implementing, right? To teach developers that the need for a memory layer and AI applications, right? Eventually, we're going to kind of, we are in the process of taking this open source project and transforming this into a product, a managed service in our cloud. But the idea of it, the APIs, the programming model, you can search on this Redis Agent Memory Server project, right? So what I have done, right, in order to leverage the Agent Memory Server is a server, as the name implies, right? It's something that you're going to spin up either by a container, a server, a VM, or you're going to like host somewhere, build a cluster out of it, whatever. But for the LangChain4J perspective, what you need to do is to come up with an implementation of what we call a chat memory store, right? So this is, let's call the persistent layer of memories in LangChain4J. So I create my own agent memory server, exposes REST API. So basically my implementation call was acted as a wrapper to those REST APIs. And then what I had to do is to instantiate that memory with chat memory, right? So the chat memory is the memory that's going to be used within a chat, a specific one, a session, as we mentioned before. So what I had to do is, oh, okay, this is my implementation of the work memory store that I've created. Here's the URL for my agent memory server. Here's the max tokens, because there's the concern about like how much tokens you're going to use so you don't explode and the amount of tokens for your model, right? And this is actually this message window chat memory. This is peculiar for LangChain4J, right? So this is an implementation that provides you with a sliding window, right? So you can set here max messages, and then by the time you have the message 11th, right? So it starts deleting the previous one, the first entry, in the position number 0, right? So it's kind of a function as a slide window, but it's backed by whatever implementation of a chat memory store that you've provided here. So that's why you associate a chat memory store to your message window, right? So in this construct here, I use something from LangChain4J, and for chat memory store, I create my own implementation, right? And then how you actually associate this for your overall implementation, you are going to same process than before, but you call this method get chat memory, right? So now you're going to provide your own, remember that get chat memory is a method that I've created, right? So, oh yeah, it returns a chat memory. So that's what we are going to associate here with get chat memory. So there you have it. With this simple change in my pipeline of creation of my chat service, I was able to achieve this. Hey, my Jarvis, my name is Ricardo. So nice to meet you, Ricardo. Hey, my Jarvis, do you recall my name? So yeah, sure. Your name is Ricardo. I remember you. So yeah, there you have it. It remembers everything. But as I mentioned before, there's two types of memory, short-term and long-term, right? So what actually happened, this is kind of a reference for SpongeBob, you probably remember this, like 5 minutes later, which is happened to be like the TTL that I've actually set on the agent member server for short-term memories, right? I asked Alexa again, hey, do you recall my name? Apologies, I don't know you, right? Because as I mentioned before, there's short-term and long-term. What is the key difference between them? Short-term is going to be memory that is actually going to be not durable at all, right? They're supposed to be temporary, right? Yeah, they have to have like a time life, like it can be 5 minutes, can be up to an hour, it can be actually up to anything you want. It's a TTL in the end of the day and the agent member server. But the point is, it's supposed to be deleted. It's supposed to be forgotten in a certain point in time. That's why certain implementation requires what we call long-term memories, right? So long-term memories is going to be something that more often than not, you're going to need to implement it. And if you ever need to implement long-term memories with LangChain4J, you are going to end up leveraging a construct, right? An interface actually called content retriever, right? So if you ever actually implemented like any RAG applications, the name is intentional here because this is how you implement a RAG in LangChain4J. So you're going to instantiate one of the multiple content retrievers that are provided out of the box, right? But in my case specifically, I had to kind of retrieve this content, right, from the agent member server for long-term ones, like long-term memories. So I have to come up with my own implementation of this. So this is basically my implementation. I created a method called get long-term memories where I would provide this callback method here that given a query, I would call this memory service. Memory service is a implementation of my own, is a service for my like a domain model, right? That basically has the capability of search user memories, given the user ID, given the query, it returns a list of memories that are stored there. And then basically I transform this into a list that the content retriever can actually serve to the context, right? And by the time I actually finish up implement the get long-term memories, that's the only change that I have to do. So you go back to your pipeline and LangChain4J, and then you call this content retriever method, right? So, and then you pass your content retriever implementation, something that's going to ultimately return an instance of a content retriever. And there you have it. So not sure if you're getting the feeling about how LangChain4J works. Is a pipelining model. Like you basically like keep adding new functionalities by using this kind of a method calls here from the AI services. And as I mentioned before, when you start like building agentic application with LangChain4J, the programming model is similar. The only difference is that we don't call there like AI services, right? It's something else. So a good example of how this was applied to my use case, let's say, hey, Jarvis, can you confirm my dentist appointment? Or very well, it is confirmed, right? Alexa, can you verify what is for tomorrow? So let's say that I'm just asking like 10 hours later, what I have for my agenda tomorrow. And then you would pop up like things like, oh, you have a dentist tomorrow, 10 a.m. Don't forget about that, right? Or anything that's peculiar and important about tomorrow, right? That's why I told in the beginning that this idea of providing tools that explicitly teach the concept of time and dates and all of that, it was important for my use case, right? And then many minutes later, even like a day later, a week later, right? You would have the same answer if that still applies for that context. Like what I have for tomorrow, like, oh, you have a dentist 10 a.m. Or let's say that the dentist have like a passed already. Like, oh, tomorrow, remember that you have that PR that you have to review with the engineering team. So this is something that start to become very useful for my daily work. So my Jarvis like implementation start to become like a very user-friendly implementation for me, right? But then one of the changes that actually happened that was very interesting is that again, my son, that he was, oh, Dad, what is the code for the garage door? I want to come back from school. He was a little bit older than when he was growing, obviously. What is the code? I always don't remember. So every time you want it, you can ask Alexa for this. But how I would teach Alexa to remember things that were not actually memories, right? Something to remember. Right? That would be like using a kind of a storage for static content, right? So this is one of the use cases that start developing something that goes beyond user memories, either short or long. I call this knowledge bases, right? So one of the things that I had to do, and this is how LangChain4J provides you with the constructs in order to do this, you can come up with something called retrieval-augmented, right? This is an equivalent of content retriever, but with more superpowers, let's call it like this, right? So a retrieval-augmented, it's something that can take one or multiple retrievers. Think about this, like remember the content retriever interface, but now you can provide like here a map of multiple content retrievers. In my case, okay, there's the user long-term memories and there's also the general knowledge base, right? And then you can come up with something that it is provided by default with LangChain4J called language model query router, right? So why does it happen this way? You can use your own LLM, your own model that you are using to answer questions to provide a query. This happens in runtime. You actually don't have to code anything of this, but then the LLM is going to decide based on a query, right? Which one of the content retrievers is going to use, right? Which is pretty awesome if you think about it. It's kind of an intelligent router about which approach to take, which memory, because here is two examples, but let's say you have like 10 content retrievers, right? Each one of them, if you provide like a meaningful description about what each one of them do, the LLM is more than capable to decide which one is going to use to effectively answer the questions, right? So I created this method called create retrieval-augmented, and then on my pipeline, now you have to replace. You cannot have like a content retriever and a retrieval-augmented at the same time with LangChain4J. So I took it off the content retriever that only was retrieving long-term memories, and now I have one that can retrieve long-term memories and static content, right? In my case specifically, I came up here with an implementation of something that kind of I upload PDF documents with a bunch of information about the house, about documents, about our policies here for our house, and then everything is uploaded and it creates chunks and embeddings in the agent member server that can be retrieved based on a query, right? It applies some hybrid search behind the scenes. So with that in place, I was able to do things like, oh yeah, hey, my Jarvis, what is the code for wireless touchpad in the garage? So yeah, the code is 7121. So that's what you have to do. Obviously, there's a very security concern here. So I changed the code after doing this presentation. So if you try to come here in the house and try to use this code in the garage, it's not going to work, okay? So just be aware of this. All right. So another very interesting situation that I found out here is that, all right, what is the name of that person that you matched last week? Oh, it was John Doe. So where John Doe lives, right? Where he lives. And then like the implementation would always get confused about who lives, right? So you would miss a little bit of the context about what or who or where I was referring about. Like this concept of referring sometimes gets confused for the LLM. And then what you can apply this here is compressing query transformer. This is implemented out of the box by LangChain4J, another amazing thing that LangChain4J provides you out of the box. The only thing you have to provide you with is a chat model, right? So if you give a query transformer, so the same pipeline that you create the retrieval-augmented, you're going to kind of append a query transformer. So all of a sudden, so what's going to happen in runtime, if you associate this, is that in runtime, the LLM, before actually giving the final query to the backend, is going to replace he for John Doe. Or if this is a location, the actual location, and not only it or that. So this is a way for you to kind of calibrate the context that you were given to the LLM. Remember, all we're talking about here are context engineering patterns, right? So the compressing processor, the query compressing processors is one of the techniques that is also in the portfolio of the context engineering that you can apply. So the same applies for like, what is my favorite color? Oh, your favorite color is black. And also you love writing code in Java. So this is the very clear example of two different memories. Like I said that I love to write code in Java, and I've said that my favorite color is black. But when I actually ask the simple questions for what is my favorite color, right? It ended up like answering more than it was supposed to, right? Let's put it this way, right? So this is another kind of a problem of hallucination that happens with LLMs some of the times, like it gets confused with as the context grows. So what you have to do is kind of do a little bit of a trimming every time you actually kind of is formatting or engineering the context that's going to be provided to your model, right? So in order to achieve this, I've leveraged another feature of LangChain4J, amazing one called context injector, right? So with the context injector, you actually can assemble and create your own structure of how your context is going to be created and organized in memory. Think of it as a huge string with patterns, right? Like user message, then two line breaks, and then the context with brackets, etc., etc. So once you do this, you can also apply a context engineering technique called few shots, right? So you can actually provide to your system prompt a bunch of examples that teach the LLM how to best answer questions, right? So in order you actually to effectively implement this with LangChain4J, first of all, you have to structure your context in a very kind of a detailed manner. And then with the examples that you were going to provide with the few shots technique, you can actually kind of leverage that structure and said, oh, okay, if the question is asked with this intention, you are going to provide this, this, and that. And I get away with anything that's not peculiar to that question, right? So this is another technique that's very important too. So I ended up with more objective answer like this. Yeah, what is my favorite color? Yeah, your favorite color is black. So it was completely disregarding the whole like, oh, you love also Java. I love Java, by the way, but it was not the answer that I was expecting for giving my question, right? Another very peculiar situation that I found during my implementation is that, oh, yeah, Alexa, what's the PR, which PR is a priority right now? Like, let's say I'm working a bunch of PRs for my software projects. And so adding supporting for JSON and going to the dentist are your priority for this week, right? So clearly the LLM confused the notion of what is a priority, right? Yes, it's not wrong. It's one of the things that the answer itself is not wrong, but all right, going to the dentist is not the type of priority I was referring to, right? I was referring to all the PRs that are a priority. So sometimes you have to kind of is another process of trimming the context. You have to get rid of anything that is not very effective of the question that's being asked. So another technique that you can leverage that's pretty cool about LangChain4J, it gives you this abstraction called scoring model, right? It's an interface that has multiple implementations. I particularly use the Cohere scoring model because I use the Cohere service that I happen to have the subscription for it. So I provide the API key, the model name, and then what it does, right? You can use a content aggregator, re-ranking content aggregator specifically, where you associate the scoring model, you give a minimum score, so it can decide, okay, I have these two competing things here in the context. Which one of them is more relevant given the user's questions, right? So all of this implementation happens automatically, right? So I ended up with more objective answers like this. What is the PR is more of a priority right now. So, oh yeah, adding support for JSON is the priority for this week, right? So it got rid of the whole like, yeah, going to the dentist is also a priority, right? Because in terms of the scoring, right, this takes more precedence, right, in terms of the scoring model. And all of this happens dynamically. You don't have to worry about that. And another interesting thing that has started happening, actually not so interesting, right, to be honest with you, like if you happen to take a look on the GitHub repos that I've shared, you're going to see have an idea about all the services that I ended up using. So I ended up using OpenAPI, right, for the actual LLM for answering the questions. And I happen to use OpenAPI for a bunch of other things, like for re-ranking. I use Cohere. I use the LLM multiple times to kind of trim the context and all of that. And all of this, like, let's face it, like calling the LLM for every single thing in the course of a single question, right, can be expensive, right? So I kind of try to optimize my implementation in two big spheres. The token consumption starting to skyrocket my costs, right? More than I actually was expecting for a simple Alexa device at home, right? And then repetitive LLM calls, right? So the way I kind of start addressing this, the first thing that I ended up doing that there's another building implementation that LangChain4J provides you out of the box called token window chat memory, right? This is a same pattern that the sliding window provides you with, but the difference here is that it uses what we call a token estimator that is based on the max tokens, right, that you provided with. Like, let's say your max tokens is 4,096, right? So it start controlling when the context start reaching that like a threshold over there, and then start trimming very intelligently the part that is considered no longer relevant, right? That's also using your open model for this. So that was one of the optimizations that I've used. The second one is what I've called, I mean, there are questions that you might ask it that are semantically equivalent, right? So for example here, can you recall who is coming for dinner tonight? Like, oh yes, Joe and Susan. And similarly, the same question is, could you recall who I have dinner with tonight? That's the same question, just ask it differently, right? Oh, both John and Susan are here. So all of those are consuming a bunch of tokens and LLM calls for answering the very same question. So yeah, let's use caching for this, right? So one of the things that you can actually leverage for this is what we call semantic caching, right? And if you're looking for services for this, there is one called Redis LangCache, right? So Redis LangCache is a cloud service that you can use either with like Microsoft Azure or any other providers that basically does this process of caching, but not necessarily caching based on a keyword. It uses like the equivalency of words as well. So anything that's kind of a similar is going to kind of also cache, and it provides a cache hit with. So that was my implementation when I started like bringing LangCache services for my code. So this is the typical cache aside pattern, right, for in programming. So hits the cache. If there's a cache miss, go to the backend, provide updates the cache, and then you serve the new request, right? All right, we are on time, and what I would like to say finally is that two requests for you. Number one, use this QR code here to get your hands dirty with this. I created a hands-on workshop about context engineering for Java developers that basically teaches you everything that I have explained here, right? Everything in details. There are 9 labs that you can go through on your laptop by your own time, right? So you can try it out, everything that I've said here with LangChain4J. And the second QR code is my contacts on LinkedIn. So use this. Please add me on LinkedIn. I would be more than happy to answer any questions you might have about this presentation or the workshop itself. I can be literally your like a trainer in the workshop. You can like hit me on LinkedIn anytime you want. I'll be more than happy to help with this course. So I hope you have enjoyed this presentation. I hope you continue to enjoy the remaining sessions for the JDCom 26. And thank you for being here. Keep being awesome, and thank you.